So your Linux distribution is using systemd. How do you install and manage services? Stay tuned to learn how.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to more of the LPIC One Linux Administrator. In this episode, we're talking about managing services with systemd. Don, what are some of the key goals for this episode?
All right, our main goal for this episode is to show you how to enable a service under systemd to make sure that it starts when your system boots up or starts when you want it to, as well as how to interact with those services in systemd. So being able to stop, start, restart a service, and be able to monitor their progress. And then we're going to kind of wrap it up by taking a look at how to create a custom service. If you have your own application that you want to execute as a daemon in the background, we'll get a chance to see how to do that in systemd as well.
Don, in some of the episodes, we've learned that systemd is started right after the kernel starts. How do we tell systemd to load a service at boot?
All right, so the main way the systemd knows what to do is based on the target system. And we talked about targets a little bit in the last episode, but systemd is set to a default target. And that target is a text file that then lists other things that need to get loaded. And each of those kind of branch out into more and more text files that ultimately tell it what needs to be loaded, right? So the targets are kind of what powers all of this. And the targets are reading our unit files. If I take a look inside of /lib/systemd/system, inside of here, if I do an ls-l star.target, I'll find a bunch of targets, right? And the one that we're normally booting on like a server would be this multi-user.target. On a workstation, it would be graphical.target. And if we take a look at the target itself, I'm going to cat that file. So let's take a look at what's inside of it, multi-user.target. Looking inside of it, it says, all right, this is a unit. It's the multi-user system. It's got some documentation. It requires basic.target. So that means there's another target called basic.target, and whatever it calls, we need to have. And then after that, we can see that this one is designed to run after basic.target or rescue.target. And so that's basically what it's defining. And then if I go and take a look at basic.target and look there, we see this one's a unit as well. It requires sysinit.target. So there's another one that needs to be called, and so on. And then we can see where it's got requires mounts for /var and vartemp. So it needs temporary mounts and other things. Each one of these are specifying what it wants. This one wants sockets.target, timers.target, all of these different targets. And that's what's going to define how the system functions. Now, systemd reads from all of these different target files and puts them together like a puzzle to figure out all the things it needs at boot and the order it needs to load them in. I'm kind of going backwards. Multi-user was the end result. Going back, I got to basic, and now I need to go back even further to get like sockets and paths and slices, and this needs to come up after sysinit.target, so I probably need to take a look at that one and see what it needs. And if we take a peek at it, we can see that it loads after some of these other ones. So again, it just builds this whole complex tree, but it's doing it. Now notice that I don't always just see targets in here. I also see services. And if I do ls-l star.service, I can see a list of all the services that are present on my system. And there's a lot of stuff in here, stuff that you don't necessarily mess with or install, like all these systemd services, but there's other ones that you did install. If you want to install a web server, for example, then it's going to have a unit file in here somewhere. So like, let's say I wanted to install Apache, and I want to put that on my system and have it in place. Well, when I do that, what I'm going to do is say like, when I install that service, it's normally going to install the unit for me and get it put in place. So for example, if I already had that service in here, like SSH, right? So SSH is in here somewhere. Let me find it right here, ssh.service. All I would have to do is tell systemd, hey, I want you to load that. And I want you to load it at boot. And we do that by saying sudo systemctl enable SSH. Okay, so I'm telling it, hey, I want you to take that SSH service and I want you to run it at boot. And so I get a message, synchronizing state of the ssh.service with sysv service script /lib/systemd/systemd-sysv-install. That's kind of a weird one, right? That's some of where they're trying to maintain some backwards compatibility with the old sysv init. So basically just saying they want that to be enabled. But then it says executing, and there's the sysv install enable SSH. That's what's telling it I now want SSH up and running. Now, it doesn't make it up and running now. That's saying at boot time, we want it up and running. If I want it now, I could have added one extra thing. I could have said dash dash now. And that is going to flag it to start at boot, and it's going to start it right now. Now, I think it's already running on my system, so it's not a big deal, but that's what's going to get it fired up. And so that's how we interact with systemd and tell it what we want to boot.
You mentioned briefly there, Don, about the creation of those unit files. If we have new services, do we need to create those unit files?
It depends on where you get them from, right? So if you're installing from a RPM or a deb package, it's usually part of that package that it creates the unit file for you. So for example, I'm going to do a find of this folder, and I'm going to look for HTTP. And so I don't see anything in here called HTTP, and let me search for Apache, same thing. So I don't have a web server running on this system. And just to be like double super secret safe, whatever, I might want to search inside of /etc/systemd/system in case there's an override one that's in there. But I can see I don't have it there either, right? So I don't have Apache installed. I don't have services defined for it. But if I do a sudo apt install Apache 2, right? So I'm going to go ahead and install the Apache web server, right? I want to get that in here up and running. As part of the install, it's going to create all of that for me. In fact, I can see it right here on the screen. Look at this. Created symlink /etc/system_multi-user.target.once/apache2.service. It created an Apache 2 service and it linked it into the multi-user once. So when I boot into the multi-user target, it's going to load Apache. And if I look here in my file system, let me look and see if we've got that Apache service. And there it is, Apache2.service. It created the service unit for me. I didn't have to create it, right? Now, I just installed it. Is it going to run at boot? Is it running right now? Maybe, maybe not, right? Some of them are actually set to where they automatically hook themselves in to be able to boot and go, but I probably need to interact with it a little bit more. So let me do a sudo systemctl status Apache 2. All right, so here's the Apache service. I can see it's active. It's active and loaded, and it's enabled. That means when I did the install, it went full circuit for me. It created the service file. It attached it to the target. It flagged it to start at boot, and it went ahead and started it for me. And it did all of that, and all I ran was sudo apt install Apache 2.
So, Don, what if it doesn't do all that stuff?
I know, it's so nice when it does it all automatically for us. But if it doesn't, I would just have to follow this up with an extra command, right? I could do the sudo systemctl enable -- now Apache 2. And in fact, it doesn't hurt to do it again. Like, it already did it for me. But I would just have to do those steps if it didn't do it for me. And maybe I don't want it to start at boot, right? I might just want to temporarily interact with this. So I could do sudo systemctl start Apache 2, like that, to start the service up, or I could stop it or restart. Maybe I made some change, I want to restart it, so I could do that. I can do those without having to start it at boot, right? That's what the enable command does. But start, stop, restart, they're all right there, and you can get your system and your service up and running with little to no text editing.
Don, let's talk targets, all right? Does systemd automatically know, what target a service belongs to?
Sort of, not really. I'm going to back up off of that. So yes, it did in this case, right? It did in this case because the installer told it, right? We saw that in the installer, the target, the multi-user target, it didn't know anything about Apache until it was added to the multi-user target once, when that was created, right? Let's go take a look at that folder and see what all is in there. And I'm going to copy and paste that so I don't have to type it. So let me switch over to that one. And taking a look in this folder, look at all these service files, right? But they're all symlinks. They're all pointing to services in /lib/systemd/system, and it's pointing to those service files. But it's basically saying, if I boot to the multi-user target, these are all the services that I want to load. And Apache 2 is linked right in there. So that's how it knows. So, Wes, when you asked about, does it automatically know? In my case, I'm going to say it was automatic, but only automatic in the fact that I installed a package that had it defined. If it wasn't defined, then I would have to come in and symlink it. Well, when you do the systemctl enable command, that's what you're doing. You're putting this symlink in place to enable it as part of that multi-user target. So that's what's all going to kind of fall in place there to make that happen. You could define your own target. You could create custom target file, point to that. It's a lot of work. It's a super hassle. And at the end of the day, you're really just doing symlinks like this. So there's not all that much extra you have to do.
So everything is pretty much a text file, Don, here that we're seeing. Does that mean that we can create our own custom service?
You can. Yeah, I've actually done this a handful of times. Usually we're installing packages, programs from the internet, things like that install themselves. But as an example, I have a little Node.js application that I run at home. So it's a JavaScript application that runs on top of Node.js. And I have a service defined that launches Node.js and launches my JavaScript application to run it as a service. And I like that because it's easy for me to monitor if it's running. And if it fails, it's easy for me to restart it because I do it all through systemctl. And if my system reboots, I know that application will load. So that works out really well for me. But at the end of the day, the way you do that is just defining a text file, a service unit, right? Now, I mentioned earlier, we don't want to mess with things in /lib. We want to mess with things in /etc. So if I go into /etc /systemd/system and take a look in there, what I'm seeing are mostly directories and symlinks, right? So the only text files that I see are a couple of mounts for some Snap applications that I have installed. But that's an example right there of text files that have been dumped in that are customizing the way my system behaves. As I install more Snap apps, more garbage will make it in here. I'm not a fan of snaps. But let me show you how to add something like if I had a custom application. I actually do have a custom application. It's amazing. Let me show it to you. If I go into /opt/custom service/service bin, this is my binary. And when I run it, hello world, right? Amazing application. So this application is so important that I want it to run when my system boots up and I want it to stay running and I want to be able to monitor its progress. Now, this application, it runs and exits, so it's not the greatest example in the world, but we'll add it anyway. It'll be fun. So I'm going to do a sudo edit, and I'm going to create a service file for it. So I'm just going to call it custom service.service. And in many episodes, I've said, yeah, the file extension doesn't matter. In this case, it actually does, because if it's .service, .socket, all of those make a difference in what it is. So if you're making a service, it should end in .service. So I'm going to call mine custom service.service. And when I go into that, I've got an empty file. It's a little bit easier to copy some other file and then retrofit it. But for a basic service, you don't have to put all that much in there. So kind of the minimum, first off, you do have to define that this is a unit. So this is going to be a part of systemd. And Wes, help me. Did I do sudo edit? I did, yes. Okay. All right. You have to be an administrator edit here. I hate it when I write a bunch and then you go to exit and you can't save. And I'm like, crud. All right. We do probably need to give it a description. You don't have to, but it's nice. So this is going to just have a description of custom service. So I'll punch that in there. And then I'm going to say after equals network.target. If this is an application like my Node.js application at home, Node.js doesn't work very well unless you have a network stack, right? It expects you to have a web server people browse to and so on. So I would want it to load after the network target. So all the networking is up and running by the time I get in and launch this application. Then I define the service itself, right? So another set of brackets there and the word service. And my service, it may need to run as a user. If I don't specify anything here, it's going to run as root. It's going to run as the system, which I may or may not want. I might want this to run as me. So what I would do is I would say user equals dpossett. So now it knows the user context it's going to run under. Or you might have a dedicated service account for it. That's pretty common as well. I might want to define a working directory. Not necessary in the case of my application, but many applications will require it. So you'll point to where that is. Mine's in /opt/custom service. But your working directory might be in /var, right? Or in some other hard drive, wherever it is that you are storing your data. Then exec start. This is the most important line. When I call this service, what does it run? And so I'll tell it that I want it to run /opt/custom service/service bin. And you might have command line arguments that pass to it. In the case of Node.js, I have a ton. So in this case, I might say something like --port 8080 or whatever other options that application needs. You would just feed them right into here. And we may want to have something like this, restart equals always, which says if you issue a restart command, do we want this thing to restart? If we have a crash, do we want to restart it after the crash? I want that. I want my application to always be running. Not everybody wants that. Some applications, if they crash, you don't want to bring them right back up, especially database servers. because you may need to check for errors and potentially roll back transactions before you start it up. You could lose data if you automatically restart it. So that's an option that's up to you. And then lastly, the install. Here's how it's going to know where we define, where it's going to load. And I'm going to say wanted by equals multi-user.target. So that's how it's going to know that when I boot into multi-user, I want this service to load. That's that key piece. So those things right there, that's the bare minimum. There's actually a heck of a lot more you can put in this file, but this is kind of the minimum of what we need to get one up and running. I'm going to save that. So that's going to get written. I'm going to just take a look at that service file just to verify everything's good there. And now I could actually install it and load it. Okay. Now the way we do that is by saying systemctl, sudo systemctl, enable, and then what we named that service. I'll call mine custom service.service. And I can do the -- now again to make it live, like that. And there it goes. Created the symlink and it made it live. Now my application is going to load and exit, so I bet if I pull up the status of my custom service, so if I do a systemctl status custom service, I can see that it did load, but now I've got a failure. So it basically loaded and exited, which it's unhappy about because it's not actually a service. And actually, it looks like I might have gotten a true failure on this one. So looking at it here, we got that it did exit with an actual error code. Start request repeated. Oh, because I issued the enable -- now. So it tried to start and it failed out. So if it's an actual service, so what we should see is that this is happy and healthy. We get green lights, it's up and it's running and it's good. But at this point, I really only had to create one text file. I just had to create that custom service.service file. All the links and other things got created automatically for me, but now it's in place and now it'll run when my system boots, or if I want to start it up, I can pull that up whenever I want, query the status and so on.
A lot of great information with managing services with systemd. Don, what are some of the key takeaways for this episode?
All right, we learned a lot about what we can do with systemctl. Most certainly, we talked about how we can install services, where their service unit files go, where we see the text-based configuration. We saw how systemd is able to read that and load it to be able to boot services at boot time or just whenever we tell it to load something. And we saw a little bit more of syntax interacting with it. And I just remembered I left off one command I want to show you real quick. Sometimes when you make modifications to unit files, especially ones that already exist, systemd doesn't see them right away. So you might need to issue another command, which let me just show it to you real quick, is sudo systemctl daemon-reload, like that. When you run that command, that tells systemd to reread all of the unit files to look for changes. If you're creating a new file, you typically don't need it, and that's what I did. But if you modify an existing service or unit file, then you'll probably have to reload it. That's one more command, so that's another key takeaway right here at the end.
All right, ladies and gentlemen. Well, that's it for this episode, but stay tuned because we got a lot more exciting content coming up in LPIC 1 Linux Administrator.
Thank you for watching IT Pro TV.